We're here to talk about the future of cyber defense. So nothing we can say is wrong. I just want you to know, okay? So we're going to talk about artificial intelligence and zero trust, and we're going to get it all done in 30 minutes. So that's going to be a really productive system, all right? So let's go down the hallway here and introduce yourselves.
Hi, I'm Stuart McGuigan. I'm the CIO for the U.S. Department of State.
I'm Jeanette Manfra. I run the Cybersecurity division within the Cyber and Infrastructure Security Agency.
I'm Donna Dodson. I'm the Chief Cybersecurity Advisor at the National Institute of Standards and Technology.
Can you guys welcome all these? This is fantastic. We get this crowd here, right? One of the best parts of this job, I get to do these kinds of things. I get to meet really smart people to talk about really interesting things. So I can't believe I get paid money to do this. So let's jump right in. All right, Stuart, I'm throwing this first question to you. Artificial intelligence has been the buzzword for cybersecurity vendors for the last couple of years. But I'm pretty sure that most security vendors don't know the difference between artificial intelligence, machine learning, and just basically general programming. So can you kind of give us a little refresher on what those things are?
All right, and we only have 43 minutes.
Sure, yeah, knock yourself out.
And just fair warning, I started out my career in graduate school in research in AI in the 80s.
So you actually think you know what this is?
Yeah, well, you know, in the AI, thinking you know something is knowing something. But you know, what we've seen recently is really an enormous amount of progress in one area, in machine learning. And that's the ability to be able to model complex data. And it works really, really, really well if you have complex inputs and simple outputs. So I was in healthcare before. If you have lung x-rays and you can sort them into groups that are cancer, no cancer. You can have all sorts of input dimensions, and then you have a binary output, and it does very well. What it doesn't do as well is complex to complex. You end up with a combinatorial explosion of the amount of data you need, and it doesn't generalize. Like, just because you perfect a system that can diagnose lung cancer, you are starting from scratch when you want to move to pancreatic cancer. There's no sort of representation of concepts. So the bad news is it's narrow, even though it's deep. The good news is I think it's the perfect kind of methodology to be able to model all kinds of complex events. And so we're used to setting up rules. If you see the following things, take the following action. And we're driving harder and harder to autonomous systems that can actually handle events faster than people. The thing about machine learning is you can implement a deep learning model and find all sorts of patterns, and then be able to not say what they are, but just if you're seeing something outside the pattern, to be able to set up an action that would occur faster than human beings could take it. So if a legitimate user is accessing systems they have right to, communicating with other users that they have a right to communicate with, but the data is bigger than normal, it's a different pattern, then ultimately have the ability to use machine learning to instigate an action, which is to shut them off. And then you have the human factor side of thing, the service side of thing. After you've just separated the deputy secretary from the network, you have to quickly make a phone call and make an apology. Yeah. But the thing is, you know, we're advancing the stance. So I think there's a lot of hype around AI. People talk about passing the Turing test.
Yes.
I'm not sure every person I know could pass the Turing test. Just saying.
You want to explain the Turing? You guys, Donna, tell me what the Turing test is.
So. Really, we have, do people know who Turing is?
How many people know who Turing is? Come on. He is my computer science hero.
Everybody knows. Keep going.
So if you're going to mention Turing, you have to mention the Imitation Game movie with Benedict Cumberbatch. How many people have seen this? Okay, oh, it's homework for the rest of you, okay? There is actually a 2-minute explanation of what artificial intelligence is in that movie. That's the best I've ever heard. Way better than what you did, Stuart.
Well, it's not surprising.
I'm just saying. Right?
Yeah, that's a high bar.
So what's the difference between machine learning and artificial intelligence? So
artificial intelligence is a general term, and we used to say way back when the first winter came that if a machine could do it, it wasn't intelligence. I mean, that was just sort of, but machine learning is the ability to find patterns in data. And I find myself saying very obvious things, but you know, hopefully it clarifies. You can't find patterns that aren't in the data set you're using to train the model. And so you have to think very carefully about, is the data representative of all the things that you want to be able to detect? And then how often do you update, and how much instability in the model do you tolerate, because you're going to continually update based on new data. But for well-defined specific domains where you have a lot of data and you want to account for a lot of dimensions at once. So a multi-dimensional model, whether using support vector machines or other complex methods, we should be able to know what normal is in a complex network with many users running multiple applications, and then be able to really separate out the signal from the noise when it comes to something that's anomalous that we should be of concern and take action. So it's mathematics. The math is not new. The computational horsepower we can throw at it, the amount of data we can gather, that's new. But it really helps us take and find order out of what otherwise looks like chaos.
So in the sci-fi realms, right, authors and movie makers say artificial intelligence is when the software becomes aware of itself. Okay, you buying this at all?
Not even close. I mean, let's take the lung X-ray. The model is math. It doesn't know what lungs are. It doesn't know what X-rays are. It doesn't know what cancer is. It just knows for a complex set of inputs, these are the outputs, and this is the reliability that those outputs are statistically valid based on the data that has been fed so far. The idea that it could wake up and suddenly decide, you know what, I'm going to be a pulmonary surgeon, and I'm going to take over and eliminate doctors. It's a misunderstanding of what machine learning is.
So not machine learning for sure. So
Yeah.
Jeanette, you buying any of this, right? That we're not going to have a singularity happen sometime in the future?
I think in the camp of it's possible. I don't know if it's possible in our lifetime, and I'd love to have a 30-minute debate about the nature of consciousness and whether this
For this cybersecurity crowd.
this cybersecurity, it would be the most amazing cyber panel I was ever on. But I think that and Stuart really summed it up much smarter than I could ever do it. But I think where people sort of lose true people who are really into AI, and when you're talking about really the best we've got is pretty phenomenal. Artificial intelligence, being able to beat the best Go players, being able to really start to make phenomenal leaps in sort of intuition is really sort of a heart of it, because that's kind of the humanness of it, is having so much data and understanding that you can make intuitive leaps. And so I think you are starting to see some of that in some areas. I think a lot of specialists, they distinguish now between AI and artificial general intelligence. Can you teach a computer to do one set of things and they can apply it to a broader set of things that makes it more human-like? To take it back to cybersecurity, more in my area of expertise, I would say that for as far as some of the things we're trying to do to transform cyber defense on the technology side, because I think there's a lot that has to be done on the non-technology side to transform cyber defense. But machine learning does have a lot of promise. And I do not consider what we have right now and what we're using as artificial intelligence, because I'm just a bit of a purist in that, in sort of the original concepts of it. But the machine learning has gotten very good if, as Stuart said, you have the data to feed to it. And the other thing I would add is you have to have the data scientists to understand and frame the data. We've done some pilots now of, we have a lot of data actually, particularly from other federal agencies that we're able to collect through our sensor platforms and others. And our original goal was, can we start to understand more, getting into non-signature based heuristics and even into more predictive analytics. Haven't completely gotten there yet, but what we have been able to do is using some of these machine learning techniques and, really importantly, very qualified, very smart data scientists combined with very smart cyber analysts, the three of them sort of working together, have been able to do historical analysis and uncover correlations and activity that we wouldn't have otherwise discovered. So I think we're really interested in that field evolving, but a lot of people like to sell the technical solution, and we have to have the data scientists, and there's not enough of them to do that. And then you can't just have the data scientists and the tools running off on their own. You have to have people on the kind of the cyber side, all three of them talking together. So we're very interested in it. We think that it could be transformational, but there's a lot of dependencies, both on the breadth and the quality of the data set, the quality of the data scientists, and the the actions, also your expectations of what actions you think you can take from that. It's not going to change a lot of what we already have to do. Unfortunately, there's these pesky humans that we still have to deal with, who are still going to click on the link and still have to respond to the various different calls.
Well, I think it's true what Donna said was that in certain domains, okay, that machine learning algorithms can pass the Turing test or almost pass the Turing test right now, like autonomous cars, not quite there, but almost there. What is the thing for Amazon? Alexa? Alexa, right? You can tell it's sort of a robot, but...
How do you not know that?
Well, you can see in a couple of years you're not going to be able to tell, right? And just in the cybersecurity world, we've been doing machine learning on files for, 5 to 7 years, right? And the part that you were talking about is you need big, giant buckets of information in order to do machine learning. You're not going to do that on your home computer. You need petabytes of data, all right? Even bigger than that to have any kind of sense of accomplishing these missions. So the government's been doing these kinds of things. So you guys want to talk about what initiatives you're doing in the government?
Sure. So from the NIST perspective, we are very, very interested in artificial intelligence overall. We've been working with Office of Science Technology Policy on the broad question of AI, not just from the cybersecurity perspective, but within the NIST cybersecurity research and application program, we are working with our data scientists at NIST to think about trust in AI, but we actually ratcheted that back, and I think our perspective certainly matches the others and Stuart's view of AI and machine learning. So one of the things that we've noticed is that life cycle in AI, and what are the kinds of things that you need to help you think about trust in the outcome. And so it's not just, it is big petabytes of data, but you have to have more than that with the data itself and with the algorithms and with the environment that it's operating under. So to help us get started, we are getting ready to release a taxonomy as a way to be able to think about adversarial machine learning and how to look at it and how to express it, so that when organizations are thinking about deploying this sort of technology, they have a way to communicate about it and to think about it so that they can get to the point where they can trust the outcome, and that we're speaking apples and apples and oranges, because as my husband, who's in the medical community, reminds me, we just have a tendency to make up words every couple of years, and they don't always have the same meaning for the person sitting to the right and the person sitting to the left of you.
Because you just made one up, like adversarial machine learning. So that sounds really cool. I need to get me a bucket of those.
Yeah.
So tell me what that means, right?
So as people are looking at machine learning and thinking about how things can go wrong in machine learning, how, we've all seen the stop sign that gets identified as a refrigerator or a cat or something like that just because of a few pixel changes. So how can we have more trust in machine learning instead of giving the adversary the upper hand?
So it was something that Jeanette and I was talking about preparing for this panel was that we're not, the machine learning algorithms are really fantastic, but we're not really sure how they get the answer, right? So if they run the data through a bunch of nodes and they're right, but we're not sure how to do that. It's called black box programming. So how do we address that? If we don't really understand how they got the answer, how do we know that it's right?
To me.
Well, anybody. Yeah.
Well, I don't know that we don't know how it got the answer. It's just not explainable in common terms. And so I think two things are coming together. One is the need to have explainable AI. So if you're denied a mortgage, we can't just say, well, the algorithm found you insufficient, right? It's got to be, so in a mathematical sense, it's a constraint on the solution because you're going to preload terms like credit scores and other things into the model so you can explain it later. But on the other hand, as we're talking about extending models, you have to have some sort of semantic representation. You got to know what the things are. And explainable AI, I think, is one of the best pathways to be able to generalize because you're going to have put some constraints on the solution. I'm not sure that in every area you need that much explanation. I mean, if you're trying to detect what's likely to happen with some incoming ordinance, you don't want to say, well, wait a minute.
Yeah,
how do you know it's going to hit me
it,
in 20 nanoseconds? You're going to default to the machine. But when it comes to getting people to trust the outcomes, in most use cases, I think explainable AI is going to be an important part of the model.
Sure, because in most cases you don't really care. You're just going to take an action. But if it's a life and death decision that you're basing it off,
or hire, we hired you, we didn't hire you. Yeah. And then you want to sue. We better be able to explain how the model worked. And I think if you're familiar with the Amazon example of the model to pick a city based on programmers, it sounds obvious now, but their training set was inordinately white males. Mm-hmm. And so the model selected for populations that represented the training set. Whoops. So you really have to think hard about what you're using as inputs, and if you think of it as needing to be explained, then you have a better chance of detecting inherent biases that you don't want in your model.
I think what community generally talks about is verification and validation. Mm-hmm. Is just you don't want to just sort of place blind faith in the algorithms. You want to, you need to make sure that it is doing what you want it to do, but you also need to make sure that it's doing what it should do, because in the end, it's just trying to accomplish the goal that you've set forward. And I think that second part is really important. It's not just verifying the math works the way you said is it also coming in a way that makes sense, that it should be doing what you want it to do. And I think that's especially important as it starts to more and more critical infrastructure starts to use automation and starting to leverage some of these capabilities to make decisions that humans used to be able to make, or you'd have some sort of analog type backup if something was acting in a way that was not intended to. I think it's much more important than that the owners of those systems are doing that verification and validation process up front before they fully just install and automate and retire all of the people who actually knew how to run things from an analog perspective.
Donna, you were talking about before that this is not really an AI question, but if we start using machine learning algorithms to solve some of our hard problems, that becomes a data set that would be interesting to adversaries to manipulate. Mm-hmm. And what do we do about that kind of a thing?
So I think from our perspective, things like explainable AI help you think about the confidence that you have in the outcomes. But again, I keep coming back to the system perspective on this. It's not just about the algorithms, it's about trust and confidence in the data that you're using and why you trust that data and how you're protecting that data.
Is that the taxonomy thing you were talking about, or is it something else?
So the taxonomy helps you think about this across the life cycle of AI. And so instead of thinking, well, we need large data sets. Typically when we talk about machine learning, and I'll stick to that more than the broader AI question, we talk, well, we need large amounts of data. How much data do you need? And what do you need from that data? And how do you have confidence that the data that you're using with this algorithm that you have trust and confidence in, right? So it starts at that beginning piece. We haven't thought as much about the infrastructure that's supporting this entire machine learning life cycle. What kinds of security controls do we want around that? In our algorithms, what is it that we want to understand? And what's really fascinating to me is when we go and visit, and the outcomes come out, people are not thinking about the kinds of security capabilities that you want to protect those outputs so that you can go back and show during the life cycle of this process what you did to protect and to provide that confidence in the end result. So some of those basics that we need to put in all of our systems also apply to machine learning capabilities, and we look at those as kind of magic, and they're gonna take care of bad inputs all by themselves. Well, as Stuart defined, it doesn't work that way.
So, NIST just recently published a paper on these kinds of issues. Do you want to hype that?
We're about ready to publish a paper. We did one across the board on just in general on standards needed around AI. That was not particular to building that trust platform that we want to get out of this important technology. And so the next paper, or from my perspective with the NIST program, will be more on that trust perspective. But we also have some other work coming out in general around AI and producing data sets, et cetera.
So that was the commercial from NIST. Stay tuned for the future. Okay. So one of the themes of this panel is sort of myth busting about future stuff. So Jeanette, coming to you on this. Is there some myth that you want to bust about artificial intelligence in front of this crowd that most people aren't aware of, or maybe they are, but you want to highlight it?
I feel like we've already covered a lot of it. I would say, I don't know if it's a myth that most people in this room would believe in, but I think that machine learning and AI, if we want to call what currently exists AI, is not going to solve our cyber problems.
What?
We
sell that in our marketing stuff. Right?
Yeah. And I think, and related to what I said earlier, is it also doesn't negate the need for talented people to be able to run those tools, which is the biggest thing we see is people buy the tools, but they don't have the people that can understand what to do with them.
So the same problems we've had in just traditional products, you're going to see that in artificial intelligence.
Yeah, except you need even more highly qualified, rare talent than we see now.
And it's not as if our adversaries won't be doing the same sort of thing. And so, how quickly can we model out all the different events that might occur and then be able to come up with rules to guard against them, against someone who could model our defenses and then have machine learning find a way to poke holes in it. Now that may actually be an easier problem to solve once they get sufficiently sophisticated in modeling. And so all this stuff, if it's machine against machine, will be happening, at the speed of electrons, and so that'll be a whole different world.
Sounds like the Terminator 4 movie coming out. All right, Donna, myth.
So sure. So from my perspective, I think bias is still a really hard problem. Bias and understanding bias, and I think that's probably hard in all of our lives. And it's a challenge with the data sets that we are using and with the algorithms, and sometimes at least being aware of bias and being able to think about it is like the baby step on that path, but truly understanding it, we still need a lot of work.
So can I rephrase? Machine learning is going to solve a bunch of problems, but all our human stuff that we have about biases may creep in there. We need to watch out for it?
Yeah.
Okay.
Well, if it's in the data set, it's going to be
there.
the model.
Your Amazon.
But I think on the optimistic side, if you take deep learning, which finds the structure in the data, carefully curated, selected data, and you want to test for bias, go back to the hiring decision, and you want to test for gender bias, you can run a whole bunch of data through the model and then see if you can use gender to account for any of the variance in the model. Have supervised machine learning with the biases as factors into the model. And if you can account for some of the decision variance purely through gender, then that gives you a place to go. If you can't account for any of the variance based on the variables you're worried about, then you have a reason to believe that your model is at least not biased in a specific way.
So it's clear that vendors are out there trying to do machine learning algorithms and the government's out there trying to figure this out. Who should lead in this? Right? Who should be the authority on how we do this? Oh wow!
NIST.
So I think,
Yeah.
I think from the NIST perspective, we really want to be able to look at this problem like we look at everything we do at NIST and think about the measurement aspects and the kinds of things that you measure for different use cases and scenarios in machine learning and AI. And ultimately then the ultimate authority on that, just like every risk management decision. I had to bring the cybersecurity framework in there.
Sure, of course you do.
Like every risk management decision will be the organization that's relying on that, and that's what they will need to do.
So it's my observation, though, that commercial sector has a lot of resources. They're investing lots of money in this kind of research. Government's been traditionally not very good at high tech. She's leaving. Wait. Was it something I said? Government has been traditionally good at innovative, far-reaching things, all right? And so are the commercial people, I don't know, ethical enough to be in charge of this as they go forward?
Oh, absolutely.
See, Stuart.
Having come from 7 years as the CIO for Johnson & Johnson, which is a particularly ethical company, I might add. So there is a discipline in the marketplace, and at the end of the day, your customers have to trust you, particularly for complex products like medicines and medical devices, insurance, and anything that has any complexity at all. And if you're not clearly doing a good job with protecting the information, the assets, and the integrity of the products and services you provide, you will not get business. And I think it'll ultimately be as simple as that. It is a little easier to get funding. It is a little easier to scare a CEO into giving you more cyber funding, although not always easier. And in my last couple of board presentations, I was in the curious position of explaining why our cyber spend as a % of revenue was not higher. And I had to explain that that budget was not an issue. We're doing everything we could. And it was the rate of change in implementation cycles. It wasn't budgeting cycles that was standing in our way. But that was the first time in IT I've ever been asked why I wasn't spending more money by a board.
Yeah, I've never had that happen to me.
Yeah. No, it's kind of a fun problem. It's a hard question to answer. And so I think we all need to eventually pivot to say that the things we can control are not impediments to advancing our cybersecurity posture, period. And some of the ways that we get funded and we procure things don't let us do that as quickly as possible. That just means we have to change the way we think about how we build relationships, what we procure, and have to do something within a framework, well-controlled, well-managed, cost-effective framework that allows us the agility within that framework to take actions very quickly when we need to.
All right, I need to pivot to the second topic of the panel, which is zero trust. Jeanette, coming to you, all right? I've had the privilege the last couple of weeks to go out and talk to the Air Force about how they think of zero trust. This week with the Navy about how they think about zero trust. And here's my observation. Everybody has a different definition of what zero trust is. So Jeanette, what is your definition? Something we can put our hands around to talk about.
That you have no trust in the network.
Okay.
I think I would agree with you. Zero trust networking has also become sort of a buzzword. And it also, I think, is tricking people into thinking like it's a thing that you can sort of just buy and implement, and really sort of came from the zero trust architecture kind of model, which would fully endorse. And but I also think there's a lot of pieces to it that many people have been doing for a while now. Moving towards protection of the data, understanding where that data is, doing more on identity credentialing and management, which we've done for federal agencies for some time now. And so it's being a little bit facetious, but if you really just think about it as like, okay, I'm not going to actually trust my network anymore. If I don't trust that network, what do I need to put in place? And that means, understanding where that data is, protecting it, encryption, those sorts of things that I think people have been doing for a while, and it's not something that you can just sort of buy off the shelf and be good to go. There's a lot of work that goes into getting to a full zero trust architecture.
So I like what you said there. Assume that the network is compromised, right? And then if you assume the network is compromised, how do you design it so you can limit material impact to the organization because there's some insider running around your network, right?
I mean, it goes not to like kick it over to Donna, but it honestly goes to what we talked about in the cyber framework. And a lot of those principles are exactly what we kind of collectively did in the cybersecurity framework.
So
from the NIST perspective, I'll do my 30-second commercial first. We have had a chance to work very closely with DHS, with State Department, and the rest of the CIO Council through Office of Management and Budget. I have to give Jordan a big shout out from OMB, because he looked at this problem and recognized everybody was defining zero trust a little bit differently, and what it meant and what it was and what we needed and what we didn't mean. So we worked with that community, as well as very, very closely with industry, and a lot of good conversations from folks like at Palo Alto, as an example, to talk about what zero trust mean to you, because everybody does define it differently. I would define it, and our document that we put out for public comment, 800-207, folks, so we hope you take a look at that, really identifies the journey, as Jeanette just said, the journey that we are all on. But really, to me, what it means is your network and one size fits all from a trust model of your network does not work. And we need to be able to take what we have in place today and perhaps augment it a bit so that we can dial the knobs a little bit for individuals or for different roles within the organization. And we need to take into account the environment at that point in time as we think about the kinds of controls and capabilities that we want to give people, so that we understand the data, we understand the threat environment at that point in time. We understand the generalized controls that we have, and when we need to tune them up, or perhaps when we don't. If I'm sitting inside the network at NIST, it might be a very different environment from an identity management authentication standpoint than if I'm running into one of the coffee shops here in DC to get a message back to NIST quickly. And the authentication kinds of capabilities that I need there could be very different. And it allows me to tune based on many, many parameters instead of one flat, one size fits all.
So let me endorse the NIST paper. At one of the breakfasts this morning, I was being made fun of because I actually read the paper on zero trust, and because I'm a nerd, all right? So how many people?
Thank you.
Yeah, thank you. So 2 of us have read it, Donna, so that's good. My observation, though, from government approaching zero trust, Stuart, is that they try to eat the whole elephant the entire time. So can you offer any advice about how maybe you shouldn't do that?
Yeah, so the way we're thinking about it, one is I agree, zero trust is, it's a slick sounding name, but a little bit confusing because you do have some level of trust. It's just more granular, and I think maybe calling it Shades of Trust Network.
There's definitely a novel.
That's probably not right.
You could send that in as a comment.
Having N-factor authentication using correlation and other engines. So, if the secretary is in his office in HST using his device, surrounded by his people, accessing something he accesses every day, that might be the highest level of certainty and trust, and all the way down to where we're not sure it's wrong, so we don't want to kick it off yet. So that, but we're really going to restrict what happens. I think that's going to be very important. So I think the first use cases you create for whatever network slice you want to surround with this We're thinking about it is, can we make that a messaging layer, not a heavy traffic, not a heavy duty layer that runs lots of apps, that, something that has a more restricted domain of users, and so therefore is useful, but very narrow in terms of use case and complexity of the packets that are flying around the network. And can we push it to, really having, order of magnitude better authentication, and then, if we can, getting to packet level monitoring so we know what's coming from, what's being said, and where it goes. And we look at some commercial applications. I think the Chicago Board of Trade for years has had the ability to do deep packet inspection at scale, open up, interrogate the metadata, and then look at what's being bought at what price and at what quantity before it gets committed to the database. What a wonderful monitoring tool, right? That's been around for, I think, 8 or 9 years. Moore's law and everything, how far can we push that? And so if we can start with a meaningful and important use case, really try to make it complete, as opposed to, well, it's 3/4 of it is secure and 1/4 of it is still a problem. I would like to test it holistically, maybe not eating the elephant, maybe it's a hamster, I don't know. But something that's
Shane, you
doable.
like hamsters, do you? That's what you're
I wasn't intending to say that, but now I can't walk back, can I?
So Donna and Jeanette mentioned that Zero Trust is a journey, all right? And I think most people I run into think it's, like you said, Jeanette, a thing you buy to get. But there are literally a million things you can do to improve your Zero Trust architecture. And there are many things you can do right now with equipment that you already have. You don't have to go out and buy a whole new set of things. So what would be some of those things you could do like right now to get close there? Anybody got any ideas?
So I think we have, in the US government, as an example, we have some great authentication capabilities that we all have. And the first question is, are we using some of these strong authentication capabilities in all instances? And how often, you can just change the ratchet a little bit depending on what environment you're in terms of how often you need to authenticate, because there's that natural tension from users who say, I would like to log in on Monday with my PIV card, and Friday evening, I'd like to pull it out and go home and be done. And yet, if you're in some of these other environments that Stuart identified, maybe that's not an appropriate tool or the right use of that tool. Maybe you need to change the policy, right? So something as simple as those policy changes for different environments can work. We at NIST, at our National Cybersecurity Center of Excellence, are about to walk on that journey of Zero Trust and begin to build out some different security architectures that model some of the work in government and perhaps financial institutions, to be able to think about where you can use some of the knobs and lever those over time.
I would really sort of second, and particularly on access management. We're doing it through our continuous monitoring or CDM program, pushing that out and pushing out more policies. There's a lot that people can do. What we consistently see is adversaries targeting, one individual, and then because that individual had access they shouldn't have, or they were connected to something that they had no reason for their job to be connected to, they're now able to lateral throughout and gain higher level accesses. So really access management and focusing on groups and limiting that group's access to what data sets you're most concerned about. And then more sort of data protection, data loss prevention type technologies, I think, and practices would be areas that people are already doing, but it's really worth, I think, spending the resources to focus on who's got access to what parts of your network and limiting that as much as possible.
So I've heard government people talk about identity as a key. If I get identity, then I have Zero Trust, and it's not that. It's a component to it. You have to have it or you can't do Zero Trust. Can you talk about that a little bit?
It's a general rule in cybersecurity. It's about the people, it's about the policies, and it's about the technologies. And making all those work in concert with one another and maximizing the genesis of the three is truly, truly critical. So it's, and I'm reiterating what you just said, but you know, we write a policy on something like authentication and access control, and do we go back and review that over a period of time and think about how to bring it in and make it more granular now that we have much better control over our data? You know, we need to invest that kind of time, and time is a resource. Sometimes we look at budgets and things like that, and we talk about new products and services, and oh, this government agency needs more money for this product or this service. Frankly, sometimes we need more. The resource that we really need is time. And how do we get more time and make the time to sit down and look at these policies and procedures and the technology and bring them in concert back with our people?
I think I would add to identity and data protection, just sort of the traditional asset management is, you know, which we spent the first few years of our CDM program on focusing on, is just being able to understand what sort of hardware and software has access to your network. Same thing with individuals, is limiting the types of access that piece of hardware or software has, and having the right capabilities in place where you can identify when something is acting out of its parameters that you've set for it, and be able to shut that down quickly. You know, I think all of those are components. We've made a lot of progress in the federal government on the asset management side, and we're starting to make progress much more on the identity side. Then we'll, you know, data protection, of course, you know, actually being able to protect the data assets themselves, regardless of where they are in the network and who has access
That's a really good point, right? All right, so we are coming to the close of this. We're going to get on the line, takeaways, either zero trust, artificial intelligence, or both. What's the one thing you want the audience to know that they should have gotten out of this panel? Donna, let's talk.
So from a zero trust perspective, you are on that journey, whether you want to think about it or not. So use this as an opportunity to be able to go through your network and look at your policies, your practices, your people, and your technology, and start to orchestrate them.
Good.
Just to build off of Donna, I would say these are very, I would say zero trust networking is more of a paradigm and less of a technology, but the two of them that can offer some transformational advances, but it doesn't negate the need for the processes and the people to manage that.
Perfect. Stuart, you got the last word?
And if AI doesn't lead to the singularity anytime soon, I think machine learning does offer the opportunity to have data-driven policies and practices. And zero trust is not a product, but it's a way of managing a set of assets. And if you can base as much of that as possible on data and automation, you can take the human factor and a whole host of risks out of managing the security of your assets.
All excellent points. Can you all give these guys a hand? They did a fantastic job. Thank you all.